Alright, so on to the last exam review. So here we are going to start with problem number 1. Calculate the antiderivatives of the following functions. And then, if I give you the initial value, I want you to solve for c. So let's go through it. A, we have 3x squared minus 10x minus 7, and I give you that f of 0 is equal to 1. So we want to take an antiderivative. So f of x, using the power rule, so I'll use it in its full form here. I get 3x to the 2 plus 1 over 2 plus 1 minus 10x to the 1 plus 1 over 1 plus 1 minus 7x, and then plus our constant of integration c. Simplifying, we get x cubed minus 5x squared minus 7x plus c. But here I told you that f of 0 is equal to 1. So f of 0 is equal to 0 minus 0 minus 0 plus c. But f of 0, by what we were given, was also equal to 1. So this implies c is equal to 1. Therefore, my antiderivative is x cubed minus 5x squared minus 7x plus 1. Excuse me. Alright, next on to problem B. So here, g of y is equal to secant squared y. So this problem is a very important type because it basically tests, do you remember the trig stuff? Because if you don't remember it, there's very little way you're ever going to get this problem. But if you do remember it, it's super quick and easy. So what's the relationship? The derivative of tangent of x is secant squared. So g of y is tangent y, and then because I'm taking a general antiderivative, plus c. And then same thing up here. So now c, what else do we have? 4x sine of x squared. So if you're watching this the weekend before the exam, you might not know how to work one like this yet, but this is a u substitution problem. So let u be equal to x squared, then du is equal to 2x dx. So really we're doing like we would an integral here, even though there's no sign. Because what we're really doing is we're evaluating this thing, right? So we have that. And how did I know to do a u substitution? I have an x squared trapped in that sign there, and I want to get it out. So the way that I can do that is with a u substitution. And the tip-off also is I'm multiplying by 4x. So I see x squared, I see its derivative somewhat 2x, close enough. And so that tells me that this is what I want to do. So I get integral. Now I just have sine of u times 4x. And then dx I can write as du divided by 2x. That's not mathematically precise, but it'll serve well enough here. And so we're going to get integral 2 sine of u du. I can take this 2 out of the integral sign. And so finally, this is equal to minus 2 cosine u plus c. So now we have to go back and remember what was u? U was x squared plus c. So u substitution, very important. Next, part D, j of x is equal to 2x minus cosecant x cotangent x, and j of pi over 3 is equal to pi squared. So let's go ahead and find an antiderivative. So j of x by the power rule, this 2x here becomes an x squared. Different color. This minus cosecant x cotangent x becomes plus cosecant x. And then I have to add in my constant of integration c plus c. So j of pi over 3 is equal to pi over 3 squared plus cosecant pi over 3 plus c. So this gives us pi squared over 9 plus cosecant is cosine 1 over sine. So 1 over sine pi over 3. So this is equal to pi squared over 9 plus 1. Sine of pi over 3 by the unit circle is root 3 over 2. And I haven't been writing my plus c. So I get pi squared over 9 plus taking a reciprocal 2 over root 3 plus c is equal to pi squared, or c is equal to subtracting the pi squared over 9. I get 8 pi squared over 9 minus 2 over root 3. So now once again I write j of x is equal to x squared plus cosecant of x plus 8 pi squared over 9 minus 2 over root 3. So not the simplest thing to do, not the most natural constant of integration, but nothing wrong with it either. So that gets us a little over halfway through D. Keep going. E, we have k of x is equal to cosine cubed of x times sine of x. And again, we want to find antiderivatives. So here I'm going to rewrite this as an integral because we have the technology to do that now. Cubed x sine of x dx. So here I see cosines and sines. Maybe at first I'm a little bit confused. So I want to do a u substitution. And I need to let u be equal to cosine of x. And the thing that makes me think to do that is I'm taking cosine of x and raising that to a power. And I just have a sine x somewhere else. So u is equal to cosine of x. Du is therefore equal to minus sine of x dx. So I get this guy is equal to the integral of u cubed times sine of x times minus 1 over sine of x. So the only thing I did there was I can put the minus anywhere on that and it doesn't matter. du. And if you did it right, you won't have anything with x's in it left. That's how you know you did a good u substitution. Or at least if you have x stuff left, that'll tell you you didn't do a good u substitution. So I get this is equal to minus the integral of u cubed du equals minus u to the fourth over 4 plus c. But then remember, u is equal to cosine of x. So this is minus cosine to the fourth of x divided by 4 plus c. And that is my most general antiderivative. Part F. Let's keep going. So I have L of x is equal to 15x squared times x cubed plus 100 to the fourth power. And I also give you capital L of 0 is equal to 5. So again, here we have another u substitution. So it's telling me to find an antiderivative, so I can say that's the same thing as taking an indefinite integral. dx. So I let u be equal to, well, I see some x cubed stuff and I see some x squared stuff. So I'm tempted to make u x cubed plus 100. du would therefore be 3x squared dx. I have 15x squared dx. So that means I have 5 of these du's. So this becomes integral of 5 times u to the fourth du equals u to the fifth plus c by the power rule, which is now equal to x cubed plus 100 to the fourth, which is equal to capital L of x. Sorry, not to the fourth, to the fifth. I was looking at the fourth over there. So this is my antiderivative, and I forgot. No, I didn't. Yeah, this is exactly good. Okay. So we have this is equal to L of x. L of 0 is equal to 0 plus 100 to the fifth, which is also by the problem equal to 5 plus c. Plus c is equal to 5. So c is equal to 5 minus 100 to the fifth. I could write it out with all those zeros, but I'm just going to leave it as is. So then L of x is equal to x cubed plus 100 to the fifth plus 5 minus 100 to the fifth. And that is what we get for part F. Finally, G, we have a favorite. M of r is equal to r squared plus r plus 1 divided by the square root of r. So this one looks like it could be tricky, but it's really not that bad, because this is the same thing as r squared plus r plus 1 times r to the minus 1/2 equals r to the 3/2 plus r to the 1/2 plus r to the minus 1/2. And now we want to find an antiderivative. So we say capital M of r is now going to be r to the 5/2. I know I need to increase the power by 1 To end up with a 1 in front, I'm going to need to multiply by 2/5 plus I'm going to have an r to the 3/2. And again, I know that I need to end up with that. So 2/3 plus now r to the 1/2. And I multiply 1/2 by whatever number I need to get 1. So this is 2. Again, that's my intuitive way to do power rule, but you can still just use the formula for power rule and it'll give you the right answer. Just not quite as quickly. And I almost forgot, but I didn't. Plus c. And I don't think I forgot a plus c anywhere. So that concludes problem number 1.